But yeah, my name is Alekos. I've been involved with BDK since like literally the beginning, because it was pretty much me and Steve starting the project a few years ago. And now I'm not really involved with BDK anymore. So now I'm building my own stuff. I'm building a small startups. But we do use BDK in our products. So I'm here to talk about that and talk about what we're building a little bit. Yeah, so maybe I'm going to start by saying there's a bit of confusion maybe around our company because we're kind of rebranding. We used to be called 22 Devices because we started as like an hardware company. We just want to build hardware. And that was because we were trying to come up with a way to find a profitable business model on Bitcoin without sacrificing open source and yeah, like the ethos of Bitcoin. And so we figured pretty much the only thing we can do is build hardware, because at least hardware you can sell it. Software is much harder to sell and to make a profit if it's all open source. So we started as a purely hardware company, and we were thinking about what can we build, what kind of hardware can we build on Bitcoin. Obviously, you cannot build miners because that's way too expensive, too much capital upfront required. So we started building an hardware wallet, which is called Portal, which is this thing right here, if you've seen it anywhere. And so obviously we started building an hardware wallet, so an on-chain hardware wallet. And the obvious choice was, well, we should use BDK for that. Maybe it was even, I don't know, I guess maybe I was also biased by my time spent working on BDK. So I got pulled towards building this kind of product. So yeah, we've been running BDK on embedded hardware for some time now. I don't know how many other people have done it. My guess is probably not that many, but it's actually quite nice to use it because all of our firmware is written in Rust. So we just use the main library directly. We don't need any bindings or anything like that. And then you can also use BDK, obviously, on the say on the host device, so the device that speaks with the hardware wallet. In our case, we debated building an app as well. So our device is designed to be used with a smartphone. So it's kind of a mobile optimized hardware wallet. And so initially we also wanted to make an app, and obviously BDK would have been the obvious choice for the app as well. But then we realized we didn't have enough resources, enough time to build everything ourselves. So we just focused on the device, and then we kind of got it integrated in a few apps like Nunchuck and Keeper, which unfortunately they don't use BDK. We've been nagging them to use BDK. Maybe at some point they will switch to. But yeah, in terms of architecture, it's just a small embedded microcontroller. It's an STM32, so it's an ARM microcontroller, and it supports Rust quite well. So we do have, we didn't have to hack anything together. We found great kind of community support. I don't think there's official support from ST, from the producer of the microcontroller, but from the community, there's quite a lot of people building on these microcontrollers using Rust. And from our perspective, BDK kind of just worked, except for a few minor things, let's say. So I think we're still running a slightly patched version of BDK, mostly because we are very constrained by the size of the binary that we produce. So when you compile the whole project, it needs to fit on a very small flash memory, because our microcontroller has a 1 megabyte memory, which is split in two halves, so that we can have one running firmware while we update the other bank. So this is quite common for embedded devices to have two banks. So you even if the upgrade goes bad or anything, you still have the full running firmware on the other bank. So we basically have half a megabyte, and we need to fit in some graphics library, the communication stack, which happens via NFC. So all the kind of splitting up the message into chunks, reconstructing, verifying integrity, verifying encryption, because the communication with this smartphone is encrypted. And then on top of this is just kind of the basic to have a device running, which you usually kind of take for granted if you're building on mobile, if you're building on desktop or web. This is all pretty much done for you. You don't have to think about the kind of graphics library because you have a full operating system for you. But we have to think about that. And then at the end, we add BDK as well. And BDK, I think some patches were actually upstreamed already. Some others, they're still not super polished, so we haven't opened PR for those. But BDK tends to be quite big because it does a lot of things. But in our case, we only need to sign transactions. So we never create transactions, for example, because the hardware device is just a signer. It's not connected to the internet, so it cannot even know which UTXOs belong to the wallet. So we basically to BDK kind of remove some parts just to make it a bit smaller. Ideally, the compiler would do that for us, but I guess it's not. In some cases, it cannot really figure out that we're not using some of the code, and so it keeps it in the binary, and that blows up the size. But yeah, apart from the size, which I would say is like 50-50 responsibility of BDK and Rust miniscript, because that's also quite a big library. Apart from that, for us, it was just worked really well from the beginning. And as I was saying, yeah, we use BDK to basically parse. I mean, it's like BDK, Rust, Bitcoin, kind of the whole stack. We parse PSBTs, we verify all the inputs, we verify which inputs belong to the wallet based on the descriptor. Well, and speaking of descriptors, we support single sig and multi-sig right now. We want to support full arbitrary descriptors as well. But that, again, we run into size issues, code size issues when we enable like full miniscript. So by restricting it now to only single sig and multi-sig, we can keep the size a little bit lower. And we're thinking about, we're trying to come up with a way to optimize mostly Rust miniscript, I think not really BDK, to reduce the code size, because I think there's lots of margin there, so that we can then enable the full descriptor BDK potential, even though I guess most mobile wallets don't really support it yet, but at least we would be one of the few other wallets kind of supporting the old miniscript stack. And yeah, I think this is pretty much it for how we use BDK. Now, I was mentioning before, there's this kind of rebranding going on. So now we are rebranding the company to Portal. So since we were always associated with the name of the device, the name of the product, we decided it was better to just rename the whole company to it. And we're also working on a mobile app, which is not actually a wallet. So that's maybe a bit confusing, but we're trying to expand the use cases of our device. So basically our device is a device that keeps keys safe, and we started thinking about what else can we do with keys that people would want to do, not just for storing Bitcoin. And so then we came up with the idea for this other app, which is more of we like to call it like a digital identity app. So you have basically your key is your identity, so then you can use your identity to log in into stuff, or you can hold tickets which are basically eCash tokens. You can hold those tickets on your keys. So we have this idea for an app which is paired with the device, and it's like your digital life, but in a way that gives you full ownership of it. So only you know your key, so nobody can, I don't know, impersonate you because they don't know your private key, or take your tickets for a conference or whatever. So now we're kind of branching out, or is it kind of moving away a little bit from the on-chain side. So we're not very actively developing or using BDK anymore. But it's still going to remain one of the core features of the product, obviously. So we're going to keep using BDK in our products, even though most of the development now is kind of moving away from it. Yeah, I don't know. Are there any questions, or if there's anything I should, I don't know, kind of go more in depth on?
I was going to say, since you're sort of going in a new direction with some of these identity applications, is there any overlap with like what was done in the BDK stuff? Or like, is there any, I don't know, like shared cryptography that's used in both somehow? I don't know which other algorithms you need to use in your identity stuff, but curious. I believe you'd mentioned before maybe something with Noster, and is that using, I think that uses the same SecP possibly?
Yeah, so there's, I guess, lots of kind of shared parts, starting from the fact that you only have one mnemonic, and that's used for everything. So the same mnemonic is used for Bitcoin, for your wallet, and also for this identity thing, obviously with like a different derivation. So you know, don't have kind of collisions, but it's the uh, same cryptography, bit 39, bit 32 that we use. Uh, there is so the biggest difference is uh, for the hardware wallet, on the hardware wallet side, we only keep the private key on the device because that's the main function of the device is to keep keys safe. And so the private keys for your wallet are um, never exported from the device. And we think that's fine because looking forward a few years, hopefully there's going to be more on-chain activity, so it's going to become more and more expensive to transact on-chain. And so we expect people to only transact on-chain like every once in a while. So we see it as kind of like wire transfer, maybe even less frequently as wire transfers, but it's not something you use every day. So it's not like you pay with a wire transfer for dinner at a restaurant. So we think that's fine. That you need to take your device, which you probably keep somewhere safe at home, and you need to double check the transaction on the device screen. So this is the only way to get like maximum security. On the other end, for the identity thing we're doing, which is based on Noster in a sense that um, we use the Noster format, let's say, for keys. So we just use your key is an npub because we could have invented our own format, but didn't really make sense since there are quite a few kind of existing standards already. And also we use Noster for communication. So when you, for example, go on a website and you try to log in, the communication between the website and your app happens over Noster. So it's quite similar to Noster Wallet Connect in that regard. So it's two entities exchanging encrypted messages over Noster. But the thing is, all of these kind of crypto, for example, the encryption, when you are speaking with somebody, you encrypt messages so that only they can see them, and they encrypt messages so that only you can see them. Or when you sign a login challenge, so you get a login request and you sign a challenge for it. All of this happens very frequently, so like multiple times a day, and all of those actions are not really as security critical as signing an on-chain Bitcoin transaction. So what we do there is we actually export the private key from the device, but we only export, we call them sub keys. So we only export, say like a secondary lower security key. So the idea is you have your main key, your main identity, and this private key never leaves the device. And then with this main key, you sign kind of like a certificate for a sub key, which is similar to the way GPG does it or the way TLS is kind of structured. And then we export this sub key. So actually all of the crypto for the identity part is done outside of the device. So you only use the device to, for example, refresh your key. So every once in a while, your secondary key expires, maybe let's say in a year. So at least once a year, you need to go get your device and refresh, kind of move the expiration date forward. This is good, obviously, because let's say you lose that key, your device is compromised or whatever, that key has a very limited scope, has a very limited lifetime, let's say, and you need the device to kind of extend that lifetime. So there is some overlap with BDK, but it also kind of functions quite differently because for the BDK side, which is on-chain transactions, all the crypto happens on the device. And for this identity part, we basically only we authorize sub keys from the device, and then it's the mobile app that does most of the crypto, because otherwise it would be way too annoying to having to use the device for every small action you do in your daily life. So we made this decision of kind of separating the two. And yeah, the main reason is we think it's easier for people to keep a physical object safe. So our idea is we could just give you a mnemonic, you write it down on paper, and that's also supported in the app. So you don't have to buy our device. You can also use the app without the device. But if you do that, you have your main key on your phone, which means, first of all, if your phone is compromised, then your main key is compromised, not just a sub key. And then I think people tend to lose random bits of paper. They don't really, I think it's harder for people to keep something abstract like a private key safe. It's much easier to say you have this thing, or this physical object. This is your key. You don't. If you lose it, you've lost access to all your websites. You've lost all your tickets, whatever. But it's a physical object, so people are more, I don't know, I guess they're more used to keeping a physical object safe rather than just kind of an abstract number or a bunch of words. So that's why we still use the device even in the new thing we're building, but it's quite a bit of a departure from the outer world, from what we started with.
It sounds really super interesting. It sounds to me like a decentralized certificate authority system, which, the certificate authority has always been a really powerful concept, but completely centralized and capturable and censorable and all that. So that sounds super powerful. And merging it on the same keychain as your Bitcoin key, that has all this, benefits of just less keys to manage and all that. You mentioned something about an app. Do you want to talk about your app a little bit? Because I think there's some overlap there with what BDK is doing. You're using Unify, if I can understand correctly, and
Yeah,
that's something that we also use. So just that was something Thunder and Matthew and I were just talking. Thunder and yeah, Matthew and I were talking about yesterday about how you're using it, and found it potentially very useful. What you've learned there for BDK. So if you want to tell us how that's what you're doing there.
yeah. So I guess my experience with BDK turned out very useful because we we started building the core logic for our app in Rust um, for a bunch of reasons. One, obviously, safety. So we feel more confident having kind of safety critical code written in Rust, but also portability. So the fact that you can run it on multiple platforms very easily, potentially on the other device as well, because some of our library that we use for the identity things, some parts of this library will have to run on the device for, again, this kind of exporting the key. Also, for example, you would use a device when you want to change your profile. So when you want to change your Nostr profile, this needs to be signed with the main key. You cannot sign it with the sub key. So you need a device to actually update, for example, the name or the NIP05, which is your email-like thing. So we will have to run some of those parts on the device. So obviously, if we had, so the app is made with React Native, but if we had written the logic in JavaScript or TypeScript, we wouldn't have been able to run that on the device. So we started with kind of same architecture as BDK, so logic in Rust, and then we export it with bindings. We are both doing the same that BDK does and also doing the opposite in two different parts, let's say, of the code. So for the app, so we start with this kind of main Rust library, and we export some of it for the app. And again, so the app is in React Native. We are lucky that now there is like an automated generator for React Native specifically. I don't think it was there when we started with the BDK binding. So I remember the React Native bindings. I think it was Bitcoin Xavier making them. I think they were made as they were made by taking the Android bindings in Kotlin and the iOS bindings in Swift, and then kind of bridging them together, so making a library that integrates both. And this was a very manual kind of time-consuming process. Now there is like a generator for Unify directly that goes like straight to React Native. So we're actually using that, and that saves us a lot of time, as you can imagine. So yeah, this is just we got lucky with the ecosystem kind of improving compared to a few years ago. So for the app, we use this generator, which means we compile the library for Android and iOS separately, and then we just generate all the TypeScript code plus all the glue kind of logic to bridge, which is I think it's written in C++, but it's all auto-generated, so that's very nice. On the other side, from our library, which is like a monorepo kind of thing, we also export, we call them the SDK functions. So this is if you want to integrate Portal in your product. So let's say you're building a website or like any company, any startups, whatever, they want to authenticate people using Portal. We provide them an SDK so that they can just take our SDK, and there's very high-level functions like authenticate this key, request a payment from this key, issue a ticket to this key, these kind of things. And this is also like the logic itself is also implemented in Rust. It's all part of this one big library. But on this other side, so when we are facing, well, the SDK would mostly run on servers of some sort. So this is kind of designed to be integrated into any kind of automated system, which could also be like a vending machine. So we also support NFC, like contactless communication in a way. So the idea is that you would, with your phone, you would walk to a vending machine, tap your phone, and it's like Apple Pay experience. You pay straight from the Portal app. So this SDK would have to be embedded in a wide variety of kind of environments. And it's true that Rust is very portable, but it's also very time-consuming to develop and maintain the bindings. Even when they are auto-generated, you kind of have to update all of the languages individually, and then there's always something breaking, and there's that one language that you don't support, and people want it, and they cannot use it. So we made the decision of actually not building proper bindings to the Rust library. We actually built like a WebSocket server in Rust. And then in each individual language, we implement a client for this server. Because obviously WebSockets are everywhere. So there's WebSockets native libraries, or the WebSocket support for Python, obviously, Python, TypeScript, Java, but then also kind of more, I think you can connect WebSockets even on embedded hardware. If you have an ESP32, which is one of those microcontrollers that connect to the internet, there are WebSockets libraries for that too. So in that regard, we made a different decision because we figured it would have been too time-consuming to develop individual bindings for every language we ever want to support, and also because it's much harder to develop those bindings. So the advantage with the WebSocket way is that we can publish a documentation of the protocol. So we say, which is like JSON RPC, just send a JSON over and you get a JSON back. So we can publish a documentation for this and say, our SDK, we have an official SDK for TypeScript, for Java, for Python. But if you want to implement it in your own language, which we don't know, you can do it. Just read the documentation. It's a bit more annoying than getting the SDK all ready for you. But at least you can implement it. While if you're only working with pure bindings, it's very tough for somebody that doesn't know Rust to come and develop, I don't know, like Haskell bindings or something like that. So, and this is fine if you run on any kind of server environment. Maybe it's actually even better. So let's go back again to the kind of vending machine example. You can deploy one of these Rust binary, Rust server instances, and have multiple vending machines all kind of speak to the same entity, which is also probably good for removing some of the load, some of the crypto operations from smaller microcontrollers type of hardware. So I think that gives more flexibility to companies and people in general integrating Portal, because they can choose, do I want to deploy this on the same server? Do I want to deploy one instance for every server? Or do I want to deploy one kind of centralized instance for all of my microservices? And you can kind of choose. We also Dockerized this binary, so you can just get it straight from Docker. You don't need to recompile it from Rust directly. So yeah, it's both. There's both sides. So we both do bindings, because for the app, that's pretty much the only way. You cannot really run a WebSocket server locally and connect to it. It would be quite complicated. So for the app, we have to use bindings. But then on the other side, for the SDK, we are taking this other approach, which probably I wouldn't maybe recommend for BDK. I don't know. But again, that also came from my experience making the bindings on BDK and realizing how much effort goes into that. And for a small company, that's quite significant. So we had to kind of make this decision, and it's been working fine. But it's also been only a few months, so maybe at some point we realized we made the wrong choice. I don't know, but for now it's been working well.
Yeah, that's super interesting. Definitely, the bindings do take some time to put together, and yeah, I think probably for what you're doing too, you're trying to reach a whole lot of different types of applications, while BDK is really focused on just wallet. So,
Yeah.
we have just that one kind of use case. Were there any other use cases that you're focusing on for Portal besides like uh, I don't know if this was something that you've officially decided to do or not, but something like access control, or is that something maybe in the future?
Yeah. So the kind of the difficult thing is we're building more like infrastructure. So we're building like a very generic primitive, and we want to support as many use cases as possible so that people can integrate it in whichever way they want. So basically, what we support is explicitly requesting login. So that means you get a pop-up in the app that says, do you want to log into this? Do you want to authorize this? We support payments, and we actually do it through Nostro Wallet Connect. So we're not building a wallet ourselves. The idea is you have your wallet, your Lightning wallet, which is the wallet you would use for like everyday expenses, and you link that wallet to Portal. So we kind of separate the keeping money safe, which is the wallet's job, from spending policies and things like that. So for example, we can also do subscriptions. So you can get a subscription request in the app, and if you approve it, then we are gonna auto approve following payment requests from the same entity, from the same public key, as long as they match the amount and the frequency that the user accepted. So all of this is not really available in a wallet directly. So we kind of augment the power of a wallet by managing all of these policies ourselves. We're also doing the eCash ticket, which basically means you can mint, you can spawn your own Cashew mint. And if you are like an event, for example, you can issue one Cashew token for each attendee, and you send them to their Portal app. So that's kept inside the app. And then when the attendee shows up, they can send it back to you. So they can only spend it once. So they cannot kind of reuse it, and multiple people cannot access with the same token, because once you spend it, it's spent. So this is kind of the primitive. So it's like access payments, whether it's single payments or recurring payments, and also these kind of tickets thing, which could also turn into more like loyalty points or credits, because it's just eCash tokens. So you can issue, I don't know, hundreds of loyalty points to your customers, and then, I don't know, they can get discounts by redeeming them for something. And then we're focusing on both supporting the kind of purely online digital use case, in which all of this communication would happen over Nostr. So when you are speaking with a service and you're trying to log in into a platform or trying to pay or try to redeem a ticket or whatever, this is all via Nostr. And we're also working on NFC for like physical local communication. So again, there would be like access control would be the login use case applied via NFC. So that means you are physically there, you tap your phone, and that sends a login request to your phone, but it happens via NFC, and then you can send back a signed challenge and say, yeah, this is my public key, I want to enter. And depending, so for example, the building could have a whitelist of all the keys that are allowed to enter. But you can also come up with more complex use cases, like if you combine everything together, you could have something like you go to a website, you log in with your identity, you buy a ticket, and then when you show up in person, you redeem the ticket in person, and it's all the same identity, and it's all like kind of interconnected. So that's the way we see it as potentially this could be the one app that manages all your digital payments, accesses, tickets, points, whatever. And it's a few very, very simple primitives, but then you can use them online, you can use them in person, you can put them together. So for a company building a portal, they can kind of choose which parts and how they want to use them and build kind of the experience that they want to build. So yeah, there is lots of potential use cases. I guess maybe some of those we haven't even realized them yet. We're just building the primitives, just building the blocks, and then we let other companies connect those blocks in the best way they can.
Is it fair to say that that login is sort of an alternative to something like a pass key because it's got a similar
Yeah.
cryptographic without having to worry about usernames and passwords, which is such a such an improvement. It's something that should have been done a long time ago. That's all the questions I've got. I'll open it up. I want to monopolize the whole thing. I'll just say one more thing though. Sorry, October 17th, Alicos is going to be in Nashville at Bitcoin Park, and there's going to be a little hackathon, a little hacker space going on. So anybody in Nashville in October, be sure to come by in the afternoon, and you can learn more directly also from the makers at that
Yep.
event. But I'll open it up for anyone else who has any questions for Alicos.
Yeah, I don't actually remember, so I have to go back and check. I know it's, I think it was the 1.0 beta. Don't remember which one. So I think we are a few versions behind because again we have our patches, so we have to rebase our patches, which are very minimal, but still it takes time. And now most of the focus has been gone into the new thing. So I think we are a few releases behind, but at least we are on 1.0, so we're not on the old BDK. And in terms of the Nostr or CDK libraries, so the Cashew and Nostr libraries, I would say they look very similar to BDK. So I think they definitely took inspiration from BDK, but they are very complete. So I think we've only had very minor issues. There's I haven't done any PRs directly to them. One of my teammates has done, I think, a couple PRs to the Nostr libraries. I don't even remember for what, but it was very simple, very minor changes. I think it was something for getting real-time notifications when a relay is connected or disconnected, these kind of things. So because we want to show immediately in the app if we are connecting, if we're disconnected, so we can give feedback to the user. So I think, yeah, it was like a small PR to add this, but very, very minor things. We do have some patches on CDK, so on the cache libraries. But they also, so I was quite surprised because it looks like when they developed CDK, they had in mind this kind of parallel use case of using Cashew for arbitrary tokens, so not for Satoshis, which is the main use case. So usually people spawn Cashew mints to kind of swap. You swap with Lightning into the mint, and then you swap tokens back for in exchange of a Lightning to get a Lightning invoice paid. But they do support already this concept of units, so you can have different units on the same mint which cannot be mixed together. So the same mint can issue different kinds of tokens, and they cannot be swapped kind of among each other. So yeah, I've added only very, very few modifications there, mostly around kind of authentication, because the idea is we don't want anybody to be able to mint tokens. Because yeah, generally, like if you're a mint, again, let's say you're an event, only you want to be able to mint tickets. You don't want anybody, like any anonymous internet user, to be able to print print tokens or print tickets for free. And in general, mints instead are public, so that anybody can mint satoshis in exchange for a Lightning invoice. So I think some of the changes I made were around that. But also there I was surprised how complete it was already. So for our use case, we only had to make very small changes. And it felt a little bit like working on BDK. So I can definitely say they've probably took inspiration and kind of took a similar development style to BDK, which I think I took it as I don't know, as something to be proud of, that with BDK, we kind of establish not only a good library, but also kind of a good model to replicate for other projects as well, like Noster and Cashew. So it's quite early, so definitely not production ready. We started working on the apps in pretty much in May. There was the big, when we started kind of more actively working on it. So it's been just a couple of months. So they're both on, so the app is on the Play Store, I think as a closed beta, maybe even open beta, I don't remember, but not public, kind of not available for production. And also the iOS app, we have it on test flight. So we are kind of testing it internally, but we don't have like links to the apps yet. Or yeah, I would say it's not ready yet, definitely. Also, there are no products integrating it, so it's kind of useless now to have the app because it's not supported anywhere. I could share, maybe I will send them in the chat. I could share links to, for example, our website, which is still like a very basic landing page. It's getportal.cc. We need to, at some point, we need to update it and make it a little bit better. It's still like the very first home page we put out. We also have a Twitter account, which I think is Portal on X. So I'm going to send a link for that as well. And yeah, I think this is it. So that's mostly, so in case anybody's interested in kind of following the development, I would say go follow us on Twitter because we post quite a bit there. And in terms of kind of timeline roadmap, I think by like September, October, we should have something that's pretty much production ready so that we are confident we can tell people, okay, let's start building on this. There's going to be the meetup in October, so we hope there to kind of show it off. We hope to find people that are interested in adopting this. Obviously, it's all open source, so we're not really uh, selling anything. We just want to get adoption for this. Um, so yeah, I would say unfortunately still maybe a little bit early for to try it out, but hopefully in maybe even in just a month, maybe like end of August, we should already have something decent.
Sorry, I had one other final question about,
Mm-hmm.
are you planning some sort of Nostr integration for like managing your Nostr keys? Because I do know that that's an issue that comes up a lot where there's not really a good system. I don't know if there's any spec work going on that maybe you're also familiar with of having that sort of master key, subchild key, key management. Is that something you're also researching?
Yeah, so uh, as far as I know, there's a way, kind of an official way of doing it, which is you can, with your main key, sign a message to delegate another key. So you can say, this other key is actually basically can post on my behalf. But I don't really like that because that's the way it's done is like this is a message that is broadcasted on Nostr, so you can miss it, for example. So then you see like a post from another key, and you don't know it's actually from the main key. So I think there's a few, I don't know, kind of annoying things around that, and also it doesn't really have kind of a reproducible. I think it's all like random keys, and then you sign a certificate for another random keys. So we basically came up with our way of doing it, which is you start some cryptographic tricks. So you can start, basically we tweak the main key with a JSON of the metadata. So we tweak the main key with a JSON that says this subkey is only valid uh, from this day to this other day. So they're actually reproducible. So as long as you have a backup of your main key, and you know like the metadata for your subkey, which it's quite easy to guess, especially if you say, I don't know, I'm gonna align it to the first of the month every time. So you can also like um, get all of your subkeys in one go. And also there's other advantages. So for example, uh, it basically lets us save a few bytes. I think it was 32 bytes compared to signing a certificate that says another key is actually mine, um, kind of exploiting the fact that we are actually tweaking the main key directly. So it's kind of basically becomes kind of a smaller proof. So our plan is now we're just kind of iterating, focusing. Uh, we don't want to get distracted with um, pushing for a specification or another. So we're just kind of iterating very fast. But then our plan is when we have something that's working, we are gonna uh, go to the community and propose our standards, and we hope that they get adopted. Or maybe we're gonna have to adapt them ourselves. So the idea is we want to get to a point where it's working quite well, and then at that point we go and speak with the community, and then with the help of the community, maybe we're going to iterate more. Maybe the actual final standard is going to be a little bit different from what we have now. But I think it would be too premature to go and involve the community now, because then you have so many people pulling in different directions, and you can't really get anything done. So yeah, we have quite a few standards that I think would benefit Nostr as a whole, starting from this main subkey thing. So you don't have to have your master key on any internet connected device. You can have your master key on a fully offline device, like another wallet, and then you post on your social feed from a secondary key. But that also is going to happen. I think definitely next year. So at least 2026. We're not going to start thinking about it any sooner.
That's great. Yeah, no, I understand it. It takes time to kind of get everything put together, and spec stuff. Yeah, it should happen once it's fully baked. But yeah, I think that's potentially for you. I could see in the future as Nostr becomes more popular and more like corporate entities are using it as their main kind of public face. having like a hardware backed,
Yep.
way to issue and revoke provably authentic keys. Yeah, that could be, I think, a very powerful thing to make Nostr better. And yeah, just sounds interesting. So cool. Thanks. Thanks for telling us all about what you're doing these days. It's super interesting stuff.
Thank you.